And let's first quickly have a look at things that we have already discussed in the last class, and then we will move forward. So, in the last session, we have discussed about Kadane's algorithm, correct? We will talk about it a little bit more here. This is the algorithm that we are talking about. See, this I have, if I haven't told you earlier, let me say this now. Every algorithm that we are learning, they exist for a specific purpose. For example, if you remember two pointer algorithm, okay, you cannot apply it anywhere if the data is not sorted. So we can execute two pointer algorithm only when my data is sorted. But then remember, there are concepts like fast and slow. Then like, let's say that if I come here and then let's say there is an array, and if I put a pointer here and put a pointer here, then I am just doing I plus plus j plus plus. That's not really two pointer. Okay, for example, if I ask you to print every alternative like every value in alternate sense, for example, let's say this is the array, and what I want my printing to be like this: first 1, then 3, then 5, something like this. So you might do something like this, maybe here. So first I will print I, so 1, then I will move forward, so I will come here, j will come here, then I am going to print j 3, then I will move forward, so j will come here. I mean, it's just I am not able to come up with a proper example where I can fit it up. But then remember, just because I am putting two pointers here doesn't mean that it is a two pointer algorithm. Okay, for example, if you know about single linked list, there is a concept of fast and slow pointers. Okay, so let's say that if I have a list like this, and then if I put a pointer here and if I put another pointer here, this is not really two pointer. So you might, everywhere whenever you see there are two pointers executing on an array, that's not two pointer algorithm. Okay, two pointer algorithm is the algorithm that we execute on sorted data. Okay, and then different problem, different work. So in 2 sum we did something, in 3 sum we did something, in binary search we did something, then in count frequency we did some other stuffs. Similarly, whenever your data size is fixed, like your observation size is fixed, for example, sliding window protocol. Okay, maximum subarray sum of size k, maximum subarray sum of size k with k distinct element. So do you understand this or not, that these two problem, size k and then size k with k distinct element, they are actually same. It's just it is a twisted version of the previous problem, but we are effectively doing the same thing. And then we have discussed about the prefix suffix approach to solve some problems. Then we looked at problems like query sum, trapping rainwater, maximum best time to sell or stock. Similarly, there is another problem, Kadane's algorithm. Okay, there is another algorithm, Kadane's algorithm. The problem that I took to learn this particular algorithm is maximum sub array sum. Okay, maximum subarray sum. But then this is not really only problem that can be solved with Kadane's algorithm. That is first point. Second point, every problem that you will see with Kadane's algorithm is going to be just a twisted version of this. For example, let's have a look at some of the problems. So and then we will discuss about Kadane's algorithm one more time. Do they have it here? I don't think they have. On sliding window protocol, you see there are 164 problems. So once you have learned algorithm, I will suggest you go and try different type of problems. Don't just and forget about me, how many I have solved, how many I haven't solved. बोलो क्या कर रहा है? अच्छा ठीक है, देखना चुप चल रहा है. Okay, so we were here, sorry. So I suggest that you go and try it on your own and also have it sorted like this. So first I will just look at problems that goes in easy. Oh my God. Here easy range. Okay, so my time for looking into, I might have solved a lot of problems that you see here, probably not at this platform, somewhere else, and even if I haven't solved, it doesn't really matter now. So I am ever chasing lead code. So I will suggest that you go and do it, because for you this is the thing that is going to like shape you for the time that is about to come in front of you. Okay, so don't waste time. Even if we do not have some classes someday, I will be inconsistent for like couple of more weeks, but then this is a very long training. I am never going to end it. Okay, so as long as you need, it is going to be there. Maybe after 3 4 5 months we will end it. So we have already learned about binary search, then we have learned about here sliding window protocol. So you go and try problems on these things, and also do not, so once you take a problem, a statement, you first need to analyze it, that is there any uh, extra knowledge that is required in order to solve this problem. For example, this is a very beautiful problem, I remember it. Okay, it uses binary search only. So and it does not require any other extra knowledge, just knowledge of binary search and basic mathematics will do all well, all good with you. Okay, so you go and try all of these things on your own, and it seems like they do not have a category named Kadane's algorithm. So what we can do, we can just Kadane's algorithm problems on YouTube. अरे यार. Here, so you see they have given you numbers. So for example, lead code 53. So I can just come somewhere here and I can search. Where is that search bar now? I can search for a number like this, 53. Now I think this is the problem that we have already solved. So given an integer array, find the subarray with the largest sum and return its sum. So you see they have given you a array and they are asking you what is the maximum subarray sum, and output is 6. Clearly in this case, uh, this is the subarray that's giving you 6. 4 plus minus 1 plus 2 plus 1, correct? But then if you look here, there are more problems. Take any number, for example 1 2. Okay, see this can also be solved with Kadane's algorithm itself. Waste time to buy and sell a stock. Okay, now how can you, so we have solved this problem with prefix suffix approach, but clearly since we are looking into a range, we are going from one, like we are iterating from this point and we are going till end. We have used prefix and suffix approach to solve this particular problem, but if you scroll here and then analyze it a little bit, so these things here, okay, they don't have it written, but then maybe you can use Kadane's algorithm to solve this problem. Maybe we can choose something else, 918. So I am just trying to prove a point that every other problem that you will see, it is more or less going to be just different work with twisted version of the same thing. See, maximum sum circular array. Now what they are trying to say, the problem name itself is clear. They must be saying you something like this, that there is an array. For example, let's say this is the array that we have. Okay, 20. Then let's say we have uh, minus 30, and then let's say we have 4, and then we have 9 8 2. Okay, and they are asking you maximum subarray sum. The only thing that they did here, they said that this is a circular array. It means that after this element we have this element. Now clearly you see, in normal case this is the subarray that is giving you maximum sum. Okay, maximum subarray sum. But if I tell you that this is a circular array, then this element will also get considered after 4. So this is the subarray that will give you maximum sum, and your answer should be like this. So you see, same problem, it says they have twisted it a little bit. Okay, and there are multiple ways to solve this. We will solve this problem also in today's session itself. I mean, multiple ways kya, you can just have a hooks here, something like this. If I give you an array like this, you will be working on this. So 4 1, and after 1 we have 2 and 4. So I will just change this array like this. Okay, and then I will execute Kadane's algorithm on this array instead of executing on this. It's just we need to be aware that we do not pick an element that has already been picked. For example, if I go from here and if I select all these 3 elements, I cannot take 2 and 4 again because they are present only one time. So with little manipulation you can solve all of these problems. Then if you wish to look at couple of more things, couple of more problem, take this maximum product subarray. Now you see the same thing. The only difference is instead of sum they are asking you product, and it is not that much simple also. So you see, if you believe that you will just keep on multiplying element instead of summing it, there is going to be a lot of problem. There is a problem that we will discuss after some time, and we will solve it using bit manipulation. So that problem goes like product except self. Okay, I am telling you all of these things because if you have curious mind and if you are bored somewhere in your life, do not have anything to do, you can do all of these steps. Okay, so this problem statement goes like this, that you are given an array, you will have to prepare another answer array where every index will represent product except self. So you see, whole product is 24, except self will be 12, except self will be 6, except self will be 8. So this is your output array, but it's not that much simple. The reason being, I can give you a constraint like this such that this whole product will exceed int range, it will exceed everything. This problem is on LeetCode also. So I have this expectation from all of you that you will explore these things on your own. Okay, here. Okay, I have attempted this problem, but it seems like I haven't solved it. I this is, I have already solved it. Okay, not here, somewhere I have solved it multiple times. We will solve it here. Now you see, very simple problem statement. For example, you look at it, but then you see, when I was trying it last time, it was in 2023. A lot has changed from that time. So I have exceeded time limit, exceeded error so many times, so many times. That time also I used to be like, why, because the constraints are like that. Okay, so we will solve this problem this time using jar itself and little bit of more bit manipulation. Anyway, so what I am trying to say here, that whenever we are done discussing an algorithm, I will be taking more problems to solve using the same algorithms, but then until that time comes, it is your responsibility to go and explore things on your own. Correct? So let's quickly discuss Kadane's algorithm one more time. This problem, this algorithm is usually used to solve whenever question goes like something like this: maximum sub array sum. They can also ask you minimum subarray sum. They can also ask you like maximum subarray sum in a circular array, and so on and so forth. So but then this thing needs to be there, subarray needs to be there, otherwise you cannot implement it. Okay, now how this algorithm worked, it worked very easily. Like there were like literally only 3-4 lines of code that we will discuss, and then we will move forward. So let's say that if I give you an array like this. Okay, and now I am asking you that on this particular subarray there are n cross n plus 1 by 2, these many subarray. Out of all these subarray, give me the maximum subarray sum. Okay, which subarray has that sum, that also you can find out. Okay, so we will do that. So I am asking you that give me the subarray as well as give me the sum. So what we did, we started with two different uh, variable, answer that is initialized to minus infinity and sum that is initialized to 0. Okay, and then we are starting a train. So we will start from this point, this element, and we will go till end. So once I this minus 3 boarded the train, my sum changed to minus 3. So earlier it was 0, from 0 it will change to minus 3. Now think about it. First, you cannot come to this minus 3 and say that I will not let you board the train. Okay, the reason being, let's say that instead of minus 16, if this happens to be plus 16, this minus 6 might be a headache for this 4 and 5, but then this minus 6 and 16 together is still a plus 10 for this 4 and 5. But then this 4 and 5 cannot take 16 without minus 6, because we are talking about sub array, and sub array needs to be continuous. So if you want this 16 to be a part of this 4 and 5 bala train, you need to consume minus 6 also. What I am trying to say, that just because this element is negative does not mean that you will take the opportunity of contributing to answer away from this element. You cannot do that. Every element will have the opportunity to board the train. It's just you need to decide that whether to continue with the same train or whether to start a new train. You will have to decide it. So here, see, whenever my net sum becomes negative, whenever my net sum becomes negative, it is in my favor that I do not continue with this train. Why? Because after this, what can happen? Only two things can happen. This element will be either positive or negative. Let's say that it is a positive in this case. So if I move with the same train forward, my sum will become 1. So this 4 will complain. It will say that I myself is 4. Now you have brought some headache to me. I have reduced to 1. So it's better to continue with me. Instead of continuing, it's better to continue freshly with me. Okay, let's say that if this happens to be a negative number, so instead of minus 3, my sum will become minus 7. This is also not favorable for us. This minus 4 will say that I myself is minus 4. Why are you combining me with something that is even decreasing my net value? So if your net sum becomes negative, it's always in your favor to discard that train and start with a new train. But before we start a new train, we also need to compare our sum with our answer. Why? Because what if this is your maximum sum? I don't know what lies ahead, but what if everything is lesser than this value forward? So it's better to memorize it, and I will check that is my sum greater than my answer. Yes, it is greater than my answer. So I will update my answer, and then I will move forward. So I will again reset my sum value to 0, and then I will start from here. So 4 will come, my sum will become 4, and I will keep on checking at every point. Why? Because I do not know what lies ahead. Okay, so maybe this is your answer itself. What if every element is negative? So this 4 is your answer. So it's better to keep on checking at every step. Is my sum greater than my answer? Yes. So I will update my answer. Then I will move forward. 5. So my sum will become 9. Is my sum greater? Yes. So I will update my answer. Then here minus 6. Now you see, I cannot take this opportunity of minus 6 to board the train. I cannot go to minus 6 and say that you are negative element, you cannot board the train. You cannot do that. The reason being, see, if you do it, if you discard this train here, that okay, a negative element is coming, and let's say that if this number is plus 16, then there is a problem. Okay, so I will let it board. So my sum will become 3, and then I will check, is my current sum greater than my answer? No. So I will let it be like this itself. Move forward. 19. Is my current sum greater than my answer? Yes. So I will update my answer. And let's say this is minus 12 and this is minus 8. Then after that I will go to 2. 21. Is my sum greater than my answer? Yes. So I will make it 21. Now minus 12. I will become how much? 9. Is it greater than answer? No. Then minus 8. I will become how much? 1. Is it greater than my answer? No. So I will stop my story here, because we have reached end of the array, and by that time whatever we had in our answer, that is my answer. Do you understand this, every one of you?
Yes, sir.
Yes, sir.
Okay. Now see, in this problem, it might happen that they will ask you that, okay, I am not only interested in sum but give me the sub area also. So how we can manipulate the same logic? Let's quickly have a look. We have done the same thing with sliding window protocol also. So you see, remember when my window was sliding in sliding window protocol, like we were going like this. So whenever we had a window that is having a sum greater than my answer, I was also recording the start and end of that particular window, that okay, I have encountered a sum greater than my answer and this is a start and end of that window. Every time I encounter a sum, I will keep on updating my start and end with I and j. So we can do the same thing here also. It's just it might be a little bit different from what we did earlier. Let's quickly have a look what can we do. So I will execute Kadane's algorithm one more time on this algorithm, on this array itself, and let's load this and let's make it -2. Yeah, here 16 -2 8 -13 7 12 -15, something like this. Okay, so I will be maintaining my answer that will be initially -infinity. Then I will be maintaining a sum value that will be initially 0, and then I will be maintaining two more variable, a start and end. Both of them will be initialized with 1. Okay, why? Because I know that, sorry, 0. Why? Because I know that this is a starting of my train, and we will do the same thing. And if I make any mistake, please correct me. So I will start from here. My sum will become -3. Okay, I will check that is my sum greater than my answer. Yes, it is greater than my answer. So I will update my answer to -3, and I will also try to record a start and end. Currently my start is also here, end is also here, both are 0. Okay, and then let's do something like this. Two more variable, a start index that will be -1, end index that will be -1. So every time I update my answer, I will also update my start and end index. So I will update my start index with a start, I will update my end index with end. Okay, and then when I have encountered a scenario where I need to discard my train, so it simply means that we will do two things. First, we are going to set my sum value back to 0, and then we will move our start and end to the next index of wherever we are. So we are going to move our start like this. A start equals to I plus 1 and end also equals to I plus 1. Okay, so my start will also be here, end will also be here, I is currently here. Okay, but then in the next iteration we will be here and my start and end is also here. So now let's quickly move forward. So again, 4 will board the train, my sum will change to 4, and then I will check that is my sum greater than my answer. Yes, it is greater than my answer, so I will update my answer, and I will update my start index with a start, so it will be 1, and my end index will with end, it will be 1. Then I have moved forward one more time. Now my I is here. Okay, my sum will become 9, and then whenever we are moving forward without discarding our train, we will only move our end index. So my end is here, correct? Since I have again updated my sum, so I will again update my answer. I will again update a start index with a start, it will be 1, end index will with end, it will be 2. Okay, then move forward, -6. Okay, so my sum will become 3 and my end index will come here. Is my sum greater than my answer? No, so I will not do anything, I will just move forward. Now my sum will become 19 and my end will come here, I is here. Okay, so whatsoever element I am picking, the same element is I. So here now here end is also moving with I itself, but then that's not going to happen true all the time. Whenever we are discarding our train, we also need to reset our end, and so on so forth, correct? So here again I will be updating. So 0 1 2 3 4, So from 9 I will become 19. Since I have updated my answer, I will again update a start index as a start is still 1, and end index will become how much? 1 0 1 2 3 4. Okay, then I have come here, move one more step forward, then my sum will become 17, and my end will also keep on moving with I itself. Or you can also say that okay, if we are moving in the same train, my I itself is end. It does not matter how you do it. You might be able to manipulate I and use it as end, but then maintaining separate variables makes things clear with me. If I manipulate it with I will have to do extra processing. I don't want to do that. Okay, that is also one thing. Okay, ignore things that are not necessary. There's no harm in using an extra variable. Maybe you can come up with a approach that will use I as an end index itself, but then I don't want to do it. Okay, so I have come here, I have become 17. We cannot update, so we will just move forward. 25, my I is here, end is here. Again we need to update. So first thing that I will do, I will update my answer, then I will update my start, so it will get updated by 1 itself, and then I will update my end. So 0 1 2 3 4 5 6. Okay, 6. Now let's say that instead of minus 13, if it happens to be minus 130, so you see my I will come here, end will come here, and my sum will become minus 125. Minus 125. Now think about it. Does this statement holds true or not? I need to discard my current train, because my net sum becomes negative and it is clearly not greater than my answer. So I need to discard it. So for discarding, I will first set my sum to 0, and then I will move my start to I plus 1, which is here, end to I plus 1, which is here, and then again the same story will repeat. So think about it. In this range, if this process can get you answer for this range, it can also get you answer for whole. Okay, so think about it. In this range, isn't this my answer? This. And then a start index I have here, end index I have here, and sum I have in my sum. Let's quickly verify. 9 minus 6 3 plus 16 19, 17 plus 8 25, and 0 1 2 3 4 5 6. So am I able to fetch my start and end index also or not? Do you understand what I am doing here?
Yes, sir.
Yes, sir.
Okay, so let's do one thing. Let's quickly bring this in picture. I think we had already executed Kadane's algorithm in the same approach. We will bring our start and end index also. So here this process is giving me what? Maximum sub array sum. एक मिनट रुको यार. Okay, so here let's quickly have a look at it. So what I will do, I will be maintaining couple of more variable. A start that will be initialized with 0, end that will be initialized with 0, and then a start index that will be initialized with -1, end index that will also be initialized with -1. And the moment I encounter a sum that is greater than my answer, so I will update my start index with a start, and my end index with end. Correct, with end. Now how we will be manipulating this? So you see, every time whenever I wish to discard my train, so first thing that I will do, I will discard the train by setting sum back to 0, and then I will also set a start as I plus 1 and end as also I plus 1. Okay, the only thing is, if you are moving in the same train, your end index will also move like this, as simple as that. And then I can just come out here, and then I can say that this is my answer and this is my start index, and then this is my end index. Okay, we can do something like this. Let's see if it works or not. So it might happen that in some of the problem they will twist it like that, give me that sub array also. So in this case, what is my expected output? This, I think this is the subarray that's giving you maximum sum. So sum value is 10, 17, 13, 10, 44, and your start index should be 0, 1, 2, 3, 4, 5, 6, and end index should be 7, 8, 9, 10, 11. Let's have a look. Okay, what did we do wrong here? So every time, did I print a start and a start? We are doing something wrong. Say ei equals to I, not plus equals to 1. Once I have moved forward, I am also moving my end index forward. Arey bhai, what am I doing wrong? So it is giving me 6 6. So my start came here, end equals to plus. Hey, you need to pay attention to this, okay? All of these stuffs. So my end is currently at the ith index. I am storing my final value in the start and end. And now we have another problem. We are not getting a sum because we didn't updated our answer. So I will also update my answer to sum. So you see, these are the only thing that can happen. You will keep on making silly mistake. Here what I did, I am setting my end index, but then that's not what we are doing. In our end index, I am setting my final value. So whenever I get a sum, and then I am moving my end. So on my pointer, on my array, we have a start and end. So we should move end. That was one mistake. Another mistake, I never updated the answer. Okay, so these are the only things that you can do, but these are the only mistake that you can make. But if you pay attention, these twisted versions are not going to be a problem for you. Do you understand this implementation, every one of you, or is it a little bit confusing? Then please ask for help. Anyone, do you want me to repeat it? Guys, you need to respond.
Confusing
Yes,
as
sir.
माधव, ठीक है, चलो एक बार फिर से इसको डिस्कस करते हैं. See, I will what I will do, I will trace this for you. Okay, so this is the array that we have. So once you see now how this approach is manipulating the variables, you will get to understand. Minus 23, minus 56, 4. अगर confusing है तो बोला करो, ऐसे शर्माया मत करो. Anyway, from next time onwards, whenever you are silent, I will just take it that okay, we might need to do it one more time. Minus 4, minus 3, and 34. Okay, see, again same thing that we have done a lot of time. Whenever someone asks you to trace a code, you should always start with tracing a state of its variables. That's way it's going to be very very easy. So you see how many variables we have. First we have sum, that is initially 0. Then we have answer, that is initially minus infinity, okay, in this line. Then we have a start, that is 0. So let's do one thing. We have a start, that is 0. Then we have also end, that is 0. Then we have sum also. Okay, after this we have two more variable, a start index and end index. So let's write it here. A start index, that is -1, end index, that is -1. Now we need to run this logic on this array for every element. Let's quickly do it. My I is here. Okay, so first thing what I am doing, sum plus equals to ARR of I. So my sum will become -3. Okay, my sum will become -3. Now next thing, end equals to I. So I have set my end to 0. Okay, end to 0. A start is 0 itself because it has started from 0 by default. Now if my sum greater than my answer, is my sum greater than my answer? Yes. So first thing, I will update my answer. So my answer will become -3. Then I will update si as a start, so my si will become 0. Then I will update ei as end, so my ei will become 0. Okay, now is my sum greater than less than 0? Yes, it is less than 0. My sum is -3. Okay, so I will set my sum to 0. Then I will move my start as I plus 1, end as I plus 1. So my I value is 0, a start as end I plus 1, a start will become 1, end as I plus 1, end will also become 1. Okay, this is my first iteration. Now my I will come here. Okay, now my I will come here. Let's do the same thing. We will complete this particular uh, approach, and pay attention because it will become a mess on the screen, so you need to pay attention to things that I am writing. Again, sum plus equals to arr of 5, so my sum will become 0 plus 6, so from 0 I will become 6. Is my and then end equals to I, so end will be initialized at 1. So we are effectively updating the same value with same value. That does not make any difference, let it be. Then is my sum greater than answer? Yes, sum is 6, answer is -3. So I will update my answer. Because of this, I will update a start index si as a start 1, ei as end, that is 1. Now is my sum less than 0? No, so this it will not execute. My I will come here. Okay, now again same thing, sum plus equals to arr of 5, so sum will become 9. Okay, then a start index as a start, so yes, I will be 1 itself. Sorry, sum, and then after that end equals to I, so my end will become 2. My end will become 2, I is 2 in this case. Then is my sum greater than answer? Yes, your sum is 9, your answer is 6. So first thing, I will update my answer, then I will execute these things. Answer equals to sum, and then yes, I equals to a start. So effectively I will update 1 with 1, but then it does not make any difference. ei equals to end, ei will become 2. So you see what I am trying to maintain here, I am actually trying to maintain the current range that is having maximum sum. So you see, this is the range that is having sum. Now again, is my sum less than 0? No, so my I will move here. Okay, same story, sum plus equals to arr of 5, sum will become 17. Is my sum greater than my answer? Yes, so I will update my answer at 17. Then yes, I equals to a start. Effectively I will update 1 with 1, and then ei equals to end value is here. I have updated, and sorry, I have missed this line. I value is 3, so this will also get executed, and end will be 3, and effectively I will update my end as 3 here. Then is my sum less than 0? No, so I will move forward. Now my I will come here. Okay, pay attention again. Sum plus equals to arr of 5, so sum will become -6. If my and then end equals to I, so this will become 4. My I value is currently 4. Now is my sum greater than my answer? No, so nothing will happen. I will come here. Is my sum less than 0? Yes, so I will first update my sum, so my sum will become 0. Okay, from -6 it will become 0, and then a start equals to I plus 1. So in this case, my a start will become 4 plus 1, which is nothing but 5. Okay, and then end will also become I plus 1, which is nothing but 5. Do you understand what happened here, everyone?
Yes, sir.
Okay, now again move forward. Because of next iteration, my I will be here. My sum will become -56. Is my sum greater than my, and end will become what? So we will effectively update I like 5 with 5 itself. 0 1 2 3 4 5. Okay, that doesn't matter, one update is not going to hurt you. Now is my sum greater than my answer? No, so this will not do anything. Is my sum less than 0? Yes, so again I will reset my sum back to 0. I will set my start as I plus 1, so my start will become 6, and my end will also become 6. End is also getting initialized with I plus 1. Okay, now my I is here. Now this is 6. We have updated a start and end previously, and then because of this loop I came one step forward. Now again, sum plus equals to arr of 5, so my sum will become 4. Is my sum greater than answer? No. Is my sum less than 0? No, so nothing will happen. Then I will move forward. 4 plus 6, 10. Okay, and then int equals to I, so int will become 7. Here I am here, 0 1 2 3 4 5 6 7. Then is my sum greater than answer? No. Is my sum less than 0? No, so I will move here. From 10 I will become 17, and then my int index will change because of this line. Okay, so this time int will set to 8. Is my sum greater than answer? No. Is my sum lesser than 0? No, so nothing will happen. Then again I will move one step forward, minus 4, so 13. Okay, and then int equals to I, so int will change to 9. I am talking about this. Okay, now again none of these if holds true, so I will move one more step forward, minus 3, so 10. Okay, is my sum greater? And then I will also update int, so int will become 10. Int always getting updated with I. Okay, so I am here, that's why my int is 10. None of this if will hold true, so I will move forward, 44. Okay, now again int will also gets initialized with 11. And then is my sum greater than my answer? Yes, sum is greater than my answer, so first I will update my answer. Then I will update SI as a start. Now you see in this case your start is 6, so this will get initialized with 6, and EI with int, so it will get initialized with 11. And then move forward. Is sum lesser than 0? No, so nothing will happen, and we have reached end of the array. So we had already included this 34. So that's how this algorithm is working. It's just I am also trying to maintain the range in which we are currently looking. Do you understand this, every one of you?
Yes, sir.
If you do this one time for yourself, you will definitely get to understand. Okay, so when someone else is doing it, looking at it, okay, you can learn, but when you do it for yourself, it's going to be a cakewalk. Now here we end our discussion of Kadane's algorithm. Yesterday we have also discussed about one more problem that we had solved using bit manipulation. Okay, so I will quickly tell you that particular problem statement. So it went like this, that you are given an array, and let's say this is the array we are talking about, and then you are given a number n, let's say n value is 6. Okay, what they said, that this is a 1 to n array. 1 to n array, it simply means that in this array we will have every element in the range of 1 to n, but then there is one missing element. Clearly you can see we have 1 2 3 4 5 is missing, and then we have 6, so one element is missing. Find me that missing element. So how did we solve it using jar? Was like this. So I know that jar of same number is 0. So if I do n jar n, I will get 0. And I know that 0 jar with any other number is going to give me the same number. Okay, so 0 jar n will be n. Now we have first executed a loop on this array. So I will start with an answer variable that will be 0, and then I will execute a loop on the array, and then I will jar every element like this. Okay, once done with this, I will run another loop from 1 to n, and I will jar every I. So 1 to n, I can be these three things, 3 4 5 6. Okay, so in the same sequence in my answer itself, I will jar all of these things. Okay, yesterday I have also told you that in jar order does not matter. So n1 jar n2 is same as n2 jar n1. Okay, and you can mix it up with any number of elements. So I1 jar, I2 jar, I3, it will be same as I2 jar, I1 jar, I3. You can mix up the order. So this sequence that you see here, it can be like this. You can also write it like this. Effectively it is the same thing. Okay, 1 jar 1, 2 jar 2, 3 jar 3, 4 jar 4, then we have 5, then we have 6 jar 6. So in this sequence you see every element is repeating twice except 5. So I can write it like this, there's no harm. Now this 1 jar 1 will be 0, this 2 jar 2 will be 0, this 3 jor 3 will be 0, this 4 jor 4 will be 0, this 6 jor 6 will be 0. And see what I am left with. I am left with a sequence like this. Okay, this 5 is left, and then all 0 will reduce to a single 0, and then we will get our missing number. So we had already discussed the approach yesterday. Let's quickly look at the implementation also. It's very easy. Okay, so I will just go here, and then I am going to write something missing number, and then we will talk about it a little bit more. Let me first execute it. So let's say that I have an array, okay, 3 6 1 2 4, and then let's say I have my n value at 6. Okay, you cannot take any random n, you cannot take n equals to 10, because if you do that, there is going to be a problem. This data, it is given to you and it is said that it is meaningful. Now you see, I am going to start with a variable answer, and then first I will run a loop on my array. So I equals to 0, I less than arr dot length I plus plus. Okay, and then I will keep on joining every element to my answer like this array element. Once done with this array, I am going to run a loop from 1 to n. So I less or equals to n I plus plus, and then I will say that answer equals to answer jor I. That's all you had to do, and then I will come here, I am going to print the answer like this. Yeah, answer, and then it is going to give you the missing number. But then this is not where this problem ends. We will talk about it. First, let's quickly verify the result set. So we should get 5. Okay, and we are getting it. Do you understand the implementation, every one of you?
Yes.
And also, order of loop does not really matter at all. I can also do jor from 1 to n first, and then I can jor the elements. So this is also going to work perfectly fine. It's just at the end of the day, before we print, we need to have that sequence. Not only this, it is also not necessary that you jor the same, like jor in the same variable answer. You can also maintain different variable, like you might be able to maintain, you might do something like this array jor, and then I will have it with 0, and so we end, and then here I am going to do array jor like this array jor equals to array jor jored with arr of I. Then I can also maintain another variable like range jor, so 1 to n, and then here I will update my range jor like this. Okay, range jor equals to range jor jored with I, and then at the end of the day I will print, or I am going to update my answer like this answer equals to array jor jored with range jor. It's the same thing. So have a open mind. Okay, the way I am writing the code is not the only way it can be written. If you go and look at 10 different implementation, the 10 different people might do 10 different things. Okay, but effectively you need to look at the process and so on and so forth. Now you see this problem, I have seen people asking the same problem in different ways like this. One place they had asked it like this, that you are given an array, and it is said that in this array every element is repeating even number of times, except any one element being repeated odd number of times. So this array might look like this. Actually, remember one thing, when we discuss about bit manipulation, we don't really deal with negative numbers a lot. There are only few problems where you will see negative numbers. There's a reason, because in their binary sequence, negative numbers create complications. But then I will take some of the problem and then we will discuss about it. Here it does not really matter. Even if I put negative numbers, it is going to be the same thing, but effectively from observation perspective it will trouble you. So let's have a look at the code first. Now Look at this array. Every number is repeating even a number of times. For example, 2 is present twice, 3 is present 4 times, 8 is present twice, 17 is present 2 times, and maybe I can also go with something like this: 7 7 17 17 2 2. Again, look at it. 2 is present 4 times, 3 is present 4 times, maybe it might be present 6 times also. 17 is present 4 times, 7 is present 3 times. So every element is repeating even a number of times except any one element being repeated odd number of times, and that is 7 in this case. Find me that odd time repeating element. Can someone tell me how can you do it?
सर एक दूसरे के साथ ही जोर करा देंगे तो जो इवन नंबर ऑफ टाइम है वो जीरो हो जाएंगे, जो ऑड नंबर ऑफ टाइम है वो सिंगल एंड रह जाएगा.
See, if I just jar whole of these numbers, okay, if I just perform jar of this whole sequence, you see what we will be left with. This 2 will nullify this 2, this 2 will nullify this 2, this 17 will nullify 17, this 7 will nullify this 7, then this 17 will nullify this 17, this 8 will nullify this 8, this 3 will be gone, this 3 will be gone, and then we will be left with just this 7. Okay, so same problem, it says they had changed the a statement, and on lead code I think they had asked it like this: that given an array, every element is repeating twice except any one element being repeated only one time. So that is also the same problem itself. If I talk about this, every element is repeating even number of time except any one element being repeated odd number of time. Or if you look at this, okay, every element is repeating twice except one element being repeated one time. You can also say it like this: every element is repeating even number of time except any one odd number of time. So it's the same problem, they have just changed the a statement. Now I will leave you with a problem for today, and I want you to give it very heavy thought before you come next in this class. I remember a couple of years back I got interviewed at Infosys. There they asked me this problem. Okay, I had that interview for a specialist programmer division, and I think a lot of you are about to go and sit in that interview, and it was purely based out of joy. You might not find this problem on internet because I haven't. And this problem, it went like this: you are given an array. Let's say this is the array we are talking about. Look at the problem statement very carefully. Okay, here what they are asking you, that your job is to make whole array jar as 0. This is the task you are supposed to be doing. If this whole jar is already 0, for example, I don't know what is this value, but then if this value is already 0, then all well, all good, you don't really need to do anything. You can just say that, sir, the task that has been allocated to me, this task is already done. By default it is done. You wanted me to do a whole array jar 0, it is already 0, so I will not do anything. But if it is not 0, then what you can do, you can pick any one element, and you can pick any one element and decrease it any number of time, and you need to pick this element such that you need to perform minimum decrement. You need to perform minimum decrement. Okay, now I will explain you what's happening here. Let's say I will explain you the problem statement, please pay attention. So currently what is the jar of whole array? So this is 3, this is 4. Okay, so 1 jar 0 1 1 1, so this value is 7. So this jor is 7. Now 7 jor 13. 13 is how much? 8 plus 4, 0, 1, 2. This is 13. Okay, jor it. 1 jor 1, 0, 1, 0, 1. Then 8. This is 8. 0, 1, 0, 0. Then 2. Already. This whole jor is already 0. Okay. So let's take one more element here. Maybe we can pick 7. Okay, so let's say this is the array, and then 7 is this, so I will be left with 7. So clearly my whole jor is not 0, my whole jor is 7. Okay, so currently this value is 7. It can be anything, let it be that it happens to be another value from this array. So okay, it can be 17, it can be 19 if I change the data. So it's clearly not 0. Now I need to do it 0. In order to do 0, what can I do? I can go to any one element, only one element. You see, you can pick only one element and decrease it any number of time. Okay, and then I can decrease that element any number of time, such that I need to decrease minimum, I need to perform minimum decrement. What it means, that let's say that there are these elements a4 and so on so forth. Let's say I went to a1, and a1 say that decrease me x number of time, decrease me 10 number of times. So currently I will make a1 as a1 minus 10, decrementing it 10 times. It simply means that I will make it a1 minus 10. And then let's say that because of this, if whole array jor is 0, then I will say that a1 can be decremented 10 times and whole array jor will be 0. अरे यार इसको a0 कर दो भाई. Then let's say that I went to a3, and a3 said that decrease me 5 times, so I will make it a3 minus 5. If it was 15, I will make it 10. So a3 is saying that decrease me 5 times and whole array jor will be 0. Then let's say that I went to a6, and a6 said that decrease me 16 times. So I will make this number a6 minus 16. So a6 is saying that decrease me 16 times and whole array jor will be 0. Let's say that if this is the scenario, then this is my answer. I will pick a3 because I need to perform minimum decrement here. I am only decrementing it 5 times. Here I am decrementing it 10 times. Here I am decrementing it 16 times. Do you understand the problem statement? And it might happen that with a1, with a4, with a2 answer is not possible. So a1 might say that okay, I cannot decrement myself and make whole jor 0. a2 might say that I cannot decrement. For example, think about it. Let's say if this is 7 and this is 13, now I know that jor is on only 13 when jor will only be 0 when these two numbers are same. So I cannot go to 7 and decrease it to make 13. Somehow if I make this 7 as 13, then my jor will be 0, but in order to make it 13 you need to increase it. Correct, you need to increase it. So with 7 answer is not possible. With 13 answer is possible. 13 will say that decrement me 6 times, I will become 7, and then 7 jor 7, I will become 0, whole jor will become 0. Do you understand what I am trying to say? That it might happen that a1, a2, a4 will say that with me answer is not possible. Is this understood? Guys,
Sorry, 0, A0, A1, A2 percentage.
sorry Chandrika, can you repeat again?
सर ये डिक्रीमेंट का बोले ना सर, A0, A1, A2 ये वाला
हाँ,
समझ में नहीं आया.
वो एक्चुअली मैंने ऐसे ही इमेजनरी नंबर्स ले लिए. ये सब कोई नंबर्स होंगे एरे में. यहाँ पे ये रहा a3. ये सब मैं बस एज्यूम कर रहा हूँ कि अगर ऐसा होता, अगर मल्टीपल आंसर होते तो हम वो वाला नंबर चूज करेंगे जिसको मिनिमम टाइम डिक्रीमेंट करना पड़े. एक मिनट रुको यार, ये प्रॉब्लम गूगल पे है या नहीं देखने दो मेरे को एक बार फिर से। डिक्रीज array element such that whole jar becomes 0. No, it is something else. Your task is to either increment or decrement it by 1. You can practice this problem also, okay? So I will give you the link, but then this is not the problem I was looking for. Wait a minute, I will explain it to you one more time. Here is the chat box. So before you come to the next class, please have it with yourself. Decrement array element to make whole jar 0, or decrement array element any time. No. Okay, let's look at the problem statement one more time, okay? Maybe they do not expose it on internet. Here, so think about it. This problem goes like this. You are given an array. Let's say that this is the array we are talking about. Let me choose my numbers carefully. So this is 3. Let's say this is 4. 4. Let's say this is 7. Okay, so let's say this is the array that's given to you, and what they are saying, नहीं इसका तो फिर से जोड़ 0 हो जाएगा, इसको 6 कर दो. What they are saying that you need to make whole jar as 0. Currently my whole jar is this, see, and then 6, 4 plus 2, 1 0 0. Currently my whole jar is 1. So if I do 3 jar 4 jar 6, it is 1. I need to make it 0. In order to make it 0, what can I do? I can pick any element and I can decrease it any number of time. So let's say that I picked 3. I went to 3 and I said that 3 jar of this sequence is 1. I need to make it 0. So tell me how many times should I decrease you? Now you see, if I do 4 jar 6, so this is 4, this is 6, my jar will be 2. So 4 jar 6 is 2. If I jar it with 2, I will become 0. If I jar 4 jar 6 with 2, I will become 0. So 3 can say that if you decrement me one time, I will become 2, and then 2 jar 4 jar 6 will be 0. Do you understand what happened here?
Yes, sir.
Guys,
Yes, sir.
okay.
Yes, sir.
Then let's say that I went to 4. I asked for that 4. Currently whole jar is 1. I want to make it 0. So tell me how many times should I decrement you? So you see, 3 and 6. So 3 is this, 6 is this. Okay, so 1 0 1. This value is how much? 5. So 4 can say that देखो 3 jar 6 is 5. I cannot decrement myself and make 5. I will only have this value as 0 when I append 5 here. I cannot decrement and make myself 5. So with me answer is not possible. Then I can go to 6. I can ask 6 that 6 whole jar is 1. I need to make it 0. So tell me how many times should I decrement you? So see, 3 jar 4. This is 3. and this is 4. So 1 1 1, this value is 7. So 6 will also tell you the same thing, that see, I cannot decrement myself and make myself 7. The reason being, if I decrement I will only be less, so with me also answer is not possible. Okay, so in this case only one element is giving you the answer, so that's going to be answer. But think about it, what if there are multiple elements that's giving you answer? Let's say that same way there is x1 that is saying me that decrement me 10 times, same way there is x2 that is saying decrement me 5 times. So out of all this, these 3 gave me answer, and this is where I need to perform a minimum decrement, so my output will be 1. Do you understand what problem statement is asking?
Yes.
Okay,
Yes,
so
sir.
I will repeat it one more time. You are given an array and your job is to make a whole jar 0. In order to make it 0, you can pick one element, decrement it any number of time, but you can do it with only one element, and you need to choose that element in such a way that you perform a minimum number of decrement. Okay, so it might happen that answer itself is not possible. So what if every element says that with me answer is not possible? So in that case print -1, otherwise print minimum number of decrement. Okay guys,
Okay, sir.
so before you come to the next class, and this problem, the link that I have sent you, it is similar to the problem that I am discussing, but it's not the same problem. So in this case they are saying you that you can either increase or decrease the number by 1. Okay, so you need to find the minimum number of increment and decrement required. Correct, so you can take some inspiration from this problem, practice this problem, or you come to the next class, then practice this one also. And I can tell you that 90% of the approach will remain same as this problem. It's just in this case we can only decrement, and we can decrement any number of time. Here you can also increase, you can also decrease, but only one time for a particular number. So think about these two problems before you come to the next session, and then we will continue our discussion. We are done for today. Is that understood to everyone? Should you have any concern, any doubt, right now is the time to ask. And I will update the recording in some time, like right away, today itself. So, should you have any concern, right now is the time to ask for help. Anyone?
नो सर।
सर आके कोड भेज देना जरा, आज के लिए कोड भेज देना ग्रुप पे।
कोड मैं भेज देता हूँ ग्रुप में। एक मिनट रुक जाओ यार, अभी भेज देता हूँ। एक बार लैपटॉप बंद कर दिया है। तो फिर ये खोलता नहीं है मेरे से। Just a moment, I will send you the code right away. I think we wrote this code today. Kadane's algorithm. You cannot see my screen, correct?
यस
You can see it.
नहीं सर
No,
नहीं।
sir.
ऐसा भी कुछ नहीं है, ठीक है, लेकिन फिर भी here. So this is the code for modified Kadane's algorithm, and then we wrote this code also to find out the missing number, correct? So here, and please give these two problems try, give it a try before you come to the next class, because you will see that suddenly this bit manipulation becomes too much of burden, like it will become too much toxic immediately. So with that problem is not toxic, like how to put it in front of